Hey guys, Space Marine 658 here. Today I am going to bring you guys another tutorial for Unreal Engine 5 C++. So today we're going to kind of talk about blueprint to C++ and vice versa communication. Now for the most part you want to avoid communicating between these two too heavily just because there is a lot of overhead. Specifically with a lot of the interaction stuff, you can run into some issues with the communication either not going through or just taking a lot more performance than you'd expect. So usually I recommend people to go more purely to C++, especially with interfaces. But we're going to kind of cover some ways you can do it, specifically because sometimes you may come across something where you just can't transition to blueprints, whether it's in a project you're working on with other people or something like that, where you just don't have the ability to go purely to C++. So you'd like the option to have ways from the C++ communicate to the blueprints and vice versa. So let's go ahead and get right into it. So what we've got here, I'm going to show a bit of an example. This is a system called projectiles. Basically, there is a close-in weapon system, or PDC, CWIS, whatever you want to call it, system I have that I recently created the projectiles in C++, just so that way I could kind of take out anything that I didn't want from, sort of like the projectile movement, since it doesn't actually have to do anything related to like physics interactions in a realistic necessarily way, because it's going through space. They don't have to slow down, there's no friction. Basically, they just need to be able to collide with things, and that's about it. So I want to kind of strip back a lot of the stuff. Plus, I've been transitioning most of my project over to C++ in general. So this is just another thing I was able to do, and while doing that I ran into some bumps with communicating because I use object pooling for my PDC cannons, and I wanted to make sure that I could do object pooling in a well thought out way. And so one of the ways I did it is currently my PDCs are still in blueprints. I haven't yet transitioned my turrets over to C++. That will happen eventually. But right now they're purely in blueprints, and with that comes a lot of logic. This is partly why it hasn't been transitioned yet. There's a lot of logic going on here, even deeper than it looks. So for example, you got get aim vector. This itself is doing quite a bit of stuff. So this definitely is a candidate for moving over to C++, converting it. So it's probably one of the next things I will work on. But until then, I wanted to at least have a way for it to work. I wanted to be able to play it and make sure that my game still worked, rather than making all these changes and then having to figure out where I broke it along the way. So with that, there is an event add to pool that I want to be able to call from the actual projectile itself. That way, when it is far enough away from, say, the launching point, it itself can actually call it even if it doesn't collide with anything. Because right now, if it doesn't collide with anything, it'll just keep going for forever if there's nothing to pool it. You can, with projectile movement, that does handle some of that stuff. So you've got like distances, you can have it kill itself, or time. But since I showed that back, I still want that feature of that, but I wanted to be able to do it in a way I can have control over. So what I've got here is, this is the blueprint side of my C++ class. So this has an event here called add to projectile pool. It takes in the parent variable that gets set when these bullets get spawned. Make sure that parent is still valid. If it is still valid, then it adds itself to the pool by calling to the parent add pool with a message. So this is a message to the parent. And then of course I have a print string here just so I can make sure it works. But if it's not valid, let's say the parent got destroyed, the ship blew up. Sorry, English is not my best language today. If the parent got blown up or some reason got destroyed from the level, this will just destroy itself. That way it's not sitting around doing things while it's not got anywhere to go. But yeah, so that's what the projectile does on the blueprint side, and this is what the turret does on the blueprint side. It just basically, when it receives that message from the projectile, it takes in that reference. So basically what this is doing is, this is a pointer to the original, actually no, it might be a reference, might be a direct reference, might be the address in memory of that bullet. But basically it takes that and adds this to an array of the pooled projectiles. So in here it adds unique, and so it adds these bullet pools here. Now in C++, the way that this is created, this little event right here, because this is the one that you want, this is how you communicate between your C++ and blueprints, is your C++ calls this event, and when it calls it, this is implemented inside of your blueprint. So basically in the C++ class, you call this, and it does this whenever that's called. This also allows you to do other things. If you have things you want in the blueprint of that class to call, you can do that way as well. So let's go ahead and look at the C++ now. So we have here, this is the actual pooling event here. So inside of my projectile, it's just a very simple setup. It's got some parents, meshes, collision box, speed, pool timer. So this is how long before the projectiles pool themselves. So they haven't collided with anything that they can collide with or anything like that after 5 seconds. At least that's what I got set to default. They will pool themselves. That way they're not sitting there doing things, running calculations. Then down here, you got the start location, start velocity, start rotation. These all get updated whenever the projectiles go to get relaunched. So basically a function I have here called fire feeds in those variables, so that way it knows where to start the new projectile rather than where it's currently at. Because whenever you freeze it somewhere, it may be somewhere where you don't want to be starting from there. You want to start from the front of the canyon. So these all get set on fire until they get pulled into here. And then here's the actual function for pool. And then for the blueprint implementable event, that's what you want to call it here. I don't actually have a definition in C++ since I'm defining it inside of the blueprint. Now, if I wanted to have it, I could have this technically be implemented 2 different locations. So if I want to do 2 different things, in theory, I could have that here. But I'm not that worried about it. And I've got some variables down here. So let's go ahead and take a look down here. So in this pool, this basically will get called whenever the projectile either has taken too long, so it hasn't collided with anything, or if it has collided with something, it'll also call it then. So basically the projectile will go away either way. So that gets called, and then when that gets called, this calls that implementable event. So the one that we don't actually have implemented here, it actually calls that event. So it'll call the blueprint version since there is an implementation there. If there was an implementation tier, I'm not sure if one takes precedence over the other, if it'll call one over the other. But I would assume that you'd probably want to only have it implemented in one place, just for the fact that you don't want to have 2 different types of logic running. Even if there is a set way, you still probably don't want to be running it that way. And then I do all my pooling functions. I'm disabling the simulate physics. I'm setting the linear velocity to nothing. I'm removing visibility, setting it to not simulate physics. And then I'm removing the actual overlapping, so it can't overlap anymore. I'm clearing the timer handles and then actually deactivating the mesh and the collision box. That way they're not seeable. And so this does all of those, and then it calls this add pool, projectile pool, which is what this is right here. So once it's cleared out everything, it goes in here, sets it to the pool, so it goes back to this turret. So this turret starts it here and says, hey, we're ready to use this. So the next time I go to get bullet, which is the function I actually call to actually grab the projectile if it's available, I first check, is there more than 0 bullets in our bullet pool? If so, find the last bullet. So you go to length -1. So it gets the last bullet on the stack, and it goes grab that bullet, and it sets it to our temporary bullet, and remove the index from the array. So that way nobody else, no other PD, well, only one PDC can is using this. But if in case you have a shared bullet pool, you could do this way. But remove the index, that way we don't fire it when we've already fired it, because you only want to fire it the one time. So remove the index, and then in here, we just feed back in that temporary bullet into the return node, as well as where we're firing it from, which is our barrel's current location rotation. Now, let's say we didn't have enough of those. We want to spawn those new bullets and then actually put them in here. You don't have to put them in the bullet pool because you're currently actively using them. They'll get pooled once they've already done their mission, whether it's the time or collision. But we go and we get our bullet, and so we'll come up here, and up here, once this gets the bullet from our array, if there's one available, and there's still a current target that's actively valid, then it's going to call fire on that specific bullet. So it gets that bullet, calls fire, which is that event we have up here, which basically just activates all the simulation of physics, sets a linear velocity of the actual projectile speed, and then basically starts all of our timers. So we feed in the location, the velocity, and the rotation. And then from there, we just check and make sure that our bullet pool isn't greater than our pool size times 2, because that's the max that I ever want to have at one time. If that is true, so it's greater than that, then we're going to remove the 0th index. So basically every time it fires, and just make sure to keep the bullet index down, though we're not overflowing with objects sitting in the pool. Now, most part, towards the beginning, there's not going to be a ton of objects in the pool. Of course, if you fire a few times and they build up, you probably want to clear those out as well. There's a couple ways you can do that. So for example, here, when this stops aiming at a target, so it no longer has a target, it checks if the bullet pool is bigger than the pool size. If so, it'll start removing indexes from the 0. And so from there, it'll remove it, and then it'll check. It'll say, is that still longer than the bullet pool? And so that way you can kind of trim down. You don't have a bunch of excess projectiles. You can remove those. Now that the combat's not happening, there's not going to be a ton of performance hit. So it's going to help bring down your average that are just sitting around. Because even while they're pooled, they do use performance. That's something people don't realize. When you make an object pool, it doesn't just instantly fix your problem. Projectiles will still take up space, so you don't want to overdo it. You want to have a set pool size that's reasonable depending on how many turrets you have, how many pools are going to be going at the same time. I prefer to have a couple. So for example, each turret right now is 25 projectiles in the pool. Now for a single ship, it might have 10 cannons, so you're looking at 250 projectiles per ship. That's a lot, and that is just from 25 bullets per CBIS cannon. Now the reason I want to have those is so that when they spawn the projectiles, it doesn't start slowing down the game massively by chunking up, because when you create and destroy objects, actors in the game, that eats performance. So you got to be careful. It's sort of a balance. You want to have a little bit of growth be possible, but at the same time, you don't want to overdo it and have so many projectiles in the pool that you end up just flatlining at a much higher millisecond time. So let's go ahead and we're going to switch over to the ships here. Once our drone gets on site, there we go. Let's give it a second. Yeah. And then we're going to go ahead and fire these missiles, and you can kind of see the sort of fire rate that we're looking at. I have lowered the fire rate just to make it a little bit more performance friendly, and it's probably something you'll want to tweak a lot as you go on. We'll give it a second here. Sometimes I've noticed with 5.1 with the RHIT thread, it'll sometimes freeze up. Apparently there's a fix coming for that in 5.1.1, but we'll see. And as we see here, boom, 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 boom. They destroy them, and then see how it's showing pooled over there on the left-hand side. So that's projectiles reaching the max range based on that time, and then they're pooled. Done. And now our performance is right back to what it was before. In fact, it's technically slightly better, just due to the fact that some of those pooled projectiles are no longer just sitting around. They actually went ahead and destroyed some of those, so probably are spawning a couple of them with higher than what they actually need to have. And that'll be kind of one of your indicators. If you start noticing that you're getting better performance after, usually it means you need to check on how many you're spawning at the beginning, and checking when you're actually removing those. But yeah. So that was kind of a bit of a tangent into projectile pooling and communication between these two. So that I'll probably label this as projectile pooling and communication. That way I kind of get an idea of what's going on here. But yeah. So that is pretty much it for this episode. If you have anything that you guys would like to see me touch on in this tutorial, definitely leave a comment down below. But otherwise, have a wonderful day and good luck and good hunting.